Hello students, chapter 4 of organic 2, reaction of enolates. We are going to start about the enolates. Carbonyl compounds containing alpha hydrogen atom when reacted with base loses its acidic proton and forms an enolate. Now here for example there is CH3, this is molecule carbonyl compound, and CH2 I am showing separately, and the one H just to show these all H are, for example here C double bond O and CH3. These all hydrogens, they are alpha hydrogen because they are bonded with alpha carbon. So they all are acidic, but just to show you that if we remove any one hydrogen by the reaction of OH base in presence of base, it will attack on this hydrogen, it abstract one acidic hydrogen, and this bond will come on this carbon and it form carbene ion. Carbene ion is CH2 with negative sign. This carbene ion, it has resonance stability and resonance structure. We can form the resonance structure of this, and we can show it. It will come here, and this oxygen, this charge will go to oxygen. So here it will be negative sign on oxygen, and double bond will come between CH2 and carbonyl carbon. This is like this. You can see oxygen negatively charged. So this is resonance structure of these two, these called enolates. Why we are discussing here enolates? Because other more reactions which we will discuss further, aldol reaction for example, various reactions are shown to proceed via enolate formation. You can see here this is stable. These enolate ions are more stable as compared to enols. Why? Because delocalization of electrons take place here, 4 electrons and 3 atoms, 1, 2, 3, 3 atoms and 4 electron, and it is conjugated, so these are more stable as compared to alkoxide. Now I am going to start about the aldol condensation. Aldol condensation, as from its name, this is related to the carbonyl compounds, and it can be self condensation or it can be cross aldol condensation reaction. In self condensation reaction, two similar molecules, we will take both aldehyde or both ketone, 2 aldehyde or 2 ketones, and the reaction product will be beta hydroxy carbonyl compound. We call it aldol. Just in the start I want to tell you why we are calling it, why we are naming it aldol, because it has aldehyde carbonyl group and hydroxyl group here, and this called beta, this is alpha, this is beta, beta hydroxy carbonyl compound. This is the product of aldol condensation, and it called aldol because aldehyde and hydroxyl group, OH alcohol group is there, so its name is aldol. Now what is the mechanism that is important to understand, that if we can discuss this aldol condensation between 2 ketones, or we can discuss this condensation between 2 aldehydes. For example, in aldehyde, what is here, you can see, if I will show you by the mechanism. For example, this is C double bond O, and here it is H, and another molecule is here C double bond O and H, here CH3. Okay, now this molecule, this is here CH3. What is the name of this compound? Acetaldehyde. Both are similar molecule. We are talking about the self condensation, self aldol reaction we are talking. Now here, first step is that reaction base, it will react with base OH, negative ion. It will attack here one hydrogen, I will show you separately. It will attack on this hydrogen, this bond will come here and it become carbene ion. In presence of sodium hydroxide, what are the conditions for aldol condensation? Number 1, that we have to select a compound, carbonyl compound, which have alpha hydrogen. Then in presence of base sodium hydroxide, this will give carbene ion, and it will be CH2 negative, C double bond O and H. Okay, this carbon ion, it will attack on another carbonyl carbon of second molecule here, CH3, and it will give, now you can join this, write this CH3, C double bond O, and here it is this H, and here this CH2 with C double bond O. This will move like this, and here it is,